Hi guys, good evening everyone. How are you all? I hope everyone is doing well. Yes. Good evening guys. Yes. How are you all? So here we are again to discuss about a new topic in solution, that is solubility. Right, I hope all of you have gone through the last two sessions that was related to the concentration terms and all of your doubts got clear. Okay, so today we'll be starting with the solubility, and this is going to be a really interesting topic guys. So before starting with the topic, I know all of you must be, yes, curious to know about your educator. Yes, so I'm Manisha Rani, your chemistry educator on Unacademy, and I have experience of online and offline teaching at reputed institutes for more than 5 years. I have done my masters from NIT Warangal and bachelor's from Delhi University. I have cracked many reputed exams like IIT JAM, CSIR, NET, and GATE, and I have given good ranks in NEET and JEE Mains through my students. So yes, guys, the most important thing, I am a plus verified tutor. So this is about me, and let me tell you about few more things regarding the classes, that all of you can get the notification regarding the classes, you can get the information, you can also get to know about, yes, you can also get to know about the different topics which are going to be discussed in the next session, and also will be sharing the notes, class notes, some of the homework sheets, right, some of the doubt resolving sessions, what are the notes for it. So we'll be sharing all of the things in the Telegram group. So all of you should, yes, join the Telegram group. And how you'll be, yes, joining it, you have either you can scan the code on the screen or you can use it, yes, you can use the link. Okay, good. So let me just tell you about a little bit regarding our special classes which occurs on the Unacademy platform. For that you have to download the Unacademy app, and when you will be choosing your goal, which is going to be ISC class 12, right, you can join some of the special classes which are absolutely free. So you can, yes, learn from your favorite educators, you can engage with the educators via polls, which is not there in the YouTube. So this is going to be really good. Yes, and you can clear your doubts in the special classes, so that is also really good. Okay guys, so talking about the special class timetable, yes, which on all days you'll be having the sessions, you'll be having 6:30 to 7:30 p.m 28th June, yes, which is today. You'll be having a discussion on name reactions from alcohols and phenol, so you guys can join it. And you'll be having on 6:30 to 7:30 p.m 5th July, you'll be having IUPAC nomenclature. I have like many of the students, they have requested about it, that they have forgot the 11th standard organic chemistry, the basics, and they want to, yes, just brush it up and they want to revise it. So yes, what you can know guys, we'll be starting with the series of topics, and in that what we'll be discussing about many of the things regarding the organic, which is going to be helpful for your class 12th organic chemistry. So yes, we are starting the series from the 5th July, and the first thing that we are studying over there, the 5th July, will be studying first thing is, yes, your IUPAC nomenclature, which is going to be helpful for all the organic units. Okay, so IUPAC nomenclature part 1 and part 2, which is there on the 12th July. So make sure everyone is joining it. Yes, now let me tell you some of the special features of Unacademy subscription, like what are few of the special qualities for it, what you can relate. Yes, the first thing, you can learn from your comfort level, you can learn live from the comfort of your home. You don't have to go anywhere, you don't have to waste the time to go to one place, like go from one place to another. Yes, so you can save that time and you can learn live from the comfort of your home. Yes, and if once you subscribe to a course, you will be having unlimited access to all the courses. You will be learning obviously from the top educators of India, and that too in one platform, that is Unacademy. And there are regular doubt resolving sessions guys. Every fourth session is a DRS session, so you can relate. Will be every class will be discussing doubts, obviously whatever doubts you have, but we have one dedicated session which is dedicated to doubts only. So whatever doubts you have, like from the last 3 sessions, you can ask that, we can discuss it so that you can relate. We do an exhaustive coverage of syllabus over here, guys. We discuss, yes, each and everything. So from scratch to the advanced we'll be going. So all of you, yes, this is a very good platform for covering the whole syllabus, and that too in a very easy and fun manner. Then you'll be having a throughout mentorship and guidance because of the community that we have. I'll be telling you a little more about the community later. And you'll be getting even the study material in the PDF formats. You'll be getting the practice tests, and very important thing, you have a live test series, guys. So live test series, from that you can get to know actually where you stand, how much concepts you have, how many concepts you have understood, and yes, where and all you have to work more, on which and all areas you should work more, so that you can relate. And you have, yes, you have the different batch courses depending upon your needs, so that also you can check. Very good. So talking about the Unacademy Plus subscription, guys, if you check the price which was there before, it was high value, but for you guys there is a good offer which is running now that yes, 20%, you will be getting 20% direct offer if you will be enrolling for the courses 27th to 30th June. If you are enrolling for plus course classes 27th to 30th June, what you will be getting, guys, you will be getting instant 10% discount. And for that, what you can do, you can use my code, which is MRIS10, and you will be getting instant 10% discount, guys. What you will be getting, you will be getting instant 10% discount. Okay, very good. So what you can relate here, yes, guys, that if you want to subscribe for the course, this is the best time because you are getting instant 10% discount. So make sure, guys, you are subscribing for our channel, yes, as well as like subscribing for our YouTube channel, as well as you are enrolling for the plus course classes, because there we'll be discussing many of the things, that there are many of the benefits for it. We'll be discussing in between the session and end of the session, so we'll be doing that. So let's just start with the topic, guys. Yes, so what is solubility? Tell me, everyone, what is solubility? So everyone should answer, what do you mean by solubility? Yeah. Hi Komal, how are you? Yes. Tell me, everyone, what is solubility? Hi Komal. So we'll be learning about solubility today, different types of solubility, how we can calculate it. So all these things we'll be learning. So solubility we'll be learning. Hi Komal, how are you? So solubility, what it is, yes, how we can define it. So it is defined as the maximum amount of solute that can be dissolved in a particular amount of solvent at a given temperature. So what is solubility? Yes, we use this term many times, right, solubility, but when we have to define it, we lag over there, like we are not able to define it properly. So what is solubility? Solubility is nothing but it is defined as the maximum amount of, yes, the maximum amount of solute, the maximum amount of solute that can be dissolved, in a particular amount of solvent, at particular temperature. Solvent at particular temperature. Very good. Komal, ability of a substance to form a solution, that we can say in like very general way. Very good. But how we can find it out? So it's the maximum amount of solute. So here we are considering the maximum amount. While the concentration, we discussed that what is concentration, the amount of solute that is dissolved in a particular amount of solvent, that we used to consider as a concentration. But what is solubility? Solubility is the maximum amount of solute that can be dissolved in a particular amount of solvent at a given temperature is called solubility. Correct? At a given temperature is called solubility. Like for example, why I'm saying given temperature, let me just little bit elaborate it. Like suppose you have a glass of water, Komal. Yes, everyone, you have a glass of water, and in that what you did, you added, right, you added a salt in it. Say first you added 1 spoon of salt, it got dissolved, right, then you added 1 more spoon, It got dissolved. Then you added 1 more spoon plus 1 spoon more salt, right? You added, okay. So what happened? It was dissolving. But the moment you added next spoon, right, it doesn't get dissolved. So maximum amount of solute that it can dissolve is 3 spoons of salt. Okay, 3 spoons of salt it can dissolve maximum. So this is the maximum amount. Now tell me, if you are having, like, after adding 3rd spoon, your 4th spoon was not getting dissolved. Okay, so what you will do, if you will increase the temperature over here, right, if you will increase the temperature, if you will heat the solution, the 4th spoon also will get dissolved or not? Tell me, guys. Yeah, this will also start getting dissolved, no, if you will increase the temperature. So that's why we also mention at a given temperature, correct? Because if you will be increasing the temperature, solubility can increase, and this is what we can understand. Clear with it? Komal, everyone? Yes, Brown Monday. Komal, everyone? Very good. So this we can relate. Now let's just talk about the next term which we have to know, that how to know whether a given substance is going to be soluble in a particular solvent or not, right? So it's going to be soluble in this or not. How we'll find it out? Like, suppose if I'm getting a water, and in water your alcohol is going to get soluble or not. In water, if I'm putting oil, whether it's going to be soluble or not. So how we can, yes, how we can understand it, so that we can relate. Okay, so that is what we can understand. Now what do you have to know? Very simple, guys. Yes, we have to know how we can find it out. So to know whether a given solute, or whether a given substance is going to be soluble in other substance, yes or no, how we can find it out. So to know whether a given substance is going to be soluble in, yes, in a particular solvent or not. So it's going to be soluble or not in a solvent, in a given solvent. How we have to check? So there are 2 rules, guys, by which you can check it. So it's very important, and when you will see also, right, so it's going to be soluble or not in a given substance or in a given solvent. How we can check it? So there are 2 rules, and this rule, if you will check, you won't be seeing in any book and all, like directly given, but yeah, like we'll be studying about it, so that anytime you're getting any question, it will be really easy for you to figure it out. So soluble or not in a given solvent. So how you can find it out? So very simple. There are 2 ways by which you can find it out. Yes, Komal, there are 2 ways by which you can find it out. So the basic rule, first thing is the basic rule. So basic rule to check, or the thumb rule to check whether the given substance, whether the given substance is going to be soluble or not, is like dissolves like. What is the basic rule to check? Yes, the basic rule to check is like dissolves like. What is that, Komal? Like dissolves like. Now what is the meaning for it? What is the meaning of it? Like dissolves like. Can you interpret it? Yes, guys. The basic rule which you can relate, that like dissolves like. Now what is the meaning of like dissolves like, guys? Very simple. That a polar solute, yes, what do you have to know? That the polar solute dissolves in polar solvent. Polar solute dissolves in polar solvent. So if you have a polar solute, you have to check. Even the solvent is also polar, it is going to get dissolved. If you have a non-polar solute dissolves in non-polar solvent. That we can relate. Your organic solute dissolves in organic solvent, and your inorganic solute dissolves in inorganic solvent. So this is a basic thumb rule, guys, by which you can check. You have to check the characteristics of solute and solvent given to you. So how you can check it? Very simple, you have to know. Yes, very simple thing. If the same nature compounds, they are going to get dissolved with each other. Right, polar will get dissolved in polar, non-polar will get dissolved in non-polar, organic will get dissolved in organic, and inorganic will get dissolved in inorganic substance. Clear with it? Yes, if substance is polar, then polar or ionic substance is dissolved in it. Very good. So because even in ionic you have a polarity, right? Positive and negative. So that also you can relate. So absolutely correct, Komal. Very good. So this is a thumb rule. So the first rule is a basic rule which we have to check. Now another rule by which we can get to know whether the given substance is going to be soluble in it or not. The second rule is what? The second rule is hydrogen bonding. So another way to check solubility is solubility is very important, guys. What is that? Hydrogen bonding. Hydrogen bonding. Yes, what is hydrogen bonding? All of you knows it. Yes, what is hydrogen bonding? So hydrogen bonding occurs when hydrogen is present near to fluorine, oxygen and nitrogen. So when hydrogen is present, yes, near to fluorine, oxygen, nitrogen, it yes, experiences a special type of dipole force of attraction, which we consider as hydrogen bonding. Correct. So how you can relate, like for example, if I say, you must have seen this thing in movies and all, that your alcohol, which is ethanol. Yes, ethanol is an organic compound, but it is soluble in water, which is inorganic. Now why it is soluble, guys? Yes, why it is soluble? Very simple. The reason is hydrogen bonding, and it is soluble in all proportions, right? It is soluble in all proportions. Why? What you can relate, on your oxygen there is a partial negative charge, yes, and hydrogen there is a partial positive charge. Correct, guys? Yes or no? On hydrogen there is partial negative, hydrogen is partial positive. Even this oxygen there is a partial negative and partial positive. So this hydrogen which is near to the oxygen, it experiences a intermolecular hydrogen bonding, and because of that, yes, you must have seen in the movie, you know, like people, what they do, they take like the alcohol and they add water in it, right? Or they take more alcohol and add water, or just alcohol like that, or very less amount of water. Or if you see the different alcoholic beverages, it is written that different concentrations. So they are soluble completely in all concentrations. Why? What is the reason? Because of the hydrogen bonding. So another way to check solubility is hydrogen bonding. First basic rule is what? Yes, first what you can relate is that, one second, guys. So what you can relate over here, guys? Yes, tell me. Just a second, guys. Yeah, so what you can relate, very simple, that here, because of the hydrogen bonding, it is completely soluble, right? So it is completely soluble in all the proportions, and that is what you can relate. Okay, very good. Now let's just talk about the next thing, that what are the factors which affect the solubility of a substance. Okay, so let's just discuss the factors affecting the solubility of a substance. Affecting the solubility of a substance. So can anyone tell what and all factors are there? Yes, Komal, everyone, tell me what and all are the factors which are affecting the solubility of a substance. Can you tell, guys? First is the nature of solute. because what solute you are taking, obviously it's going to depend on it. Yeah. Other than that, what you can relate? The nature of solvent as well. If it is depending upon nature of solute, it is also going to depend upon nature of solvent. Then what else? Yes, it depends also on temperature. Then what next? Pressure. So pressure is a dominant factor when you are taking a gas like as a solute, so that we can talk about. Otherwise, what you can relate, what are the factors in general which affects the solubility of a substance are which and all? Nature of solute, nature of solvent, temperature, pressure. So all these things, they actually affects the solubility. Okay, now what you have to know, that solubility, guys, yes, your solubility, in what and all ways we can understand. So basically solubility, when we are talking about, we consider solvent as a liquid in general. So when I'm talking about solubility, what you have to know, yes guys, the solvent we consider as liquid. We consider solvent as liquid. Okay, now what you have to know, how many cases we have to study in this. When I said that the solvent is liquid, yes, when I said the solvent is liquid, what and all things we can study here? So we'll be studying the solubility of solid in liquid. Yes, we'll be studying the solubility of solid in liquid. We'll be also studying the solubility of liquid in liquid. Yes, and we'll be also studying the solubility of gas in liquid. So the most important part which is there in our book and we have to know about in detail from where the numericals are asked is the solubility of gas in liquid. So this is a really important topic to know. Okay guys, so first let's just discuss about solubility of solid in liquid. So when I talk about solubility of solid in liquid, so it's very simple. You can relate all those factors which we have mentioned before. They all are going to affect the solubility, like nature of solute, nature of solvent, depending upon what substance you are taking. Then temperature, how it is going to change the solubility. Hi Veena, how are you? So let's just discuss solubility, how it is going to change when you have a solid in liquid. So obviously all the factors which we have discussed, they are going to be common. But when I'm taking solid in liquid, so how temperature is going to affect the solubility. So solid in liquid, let's just discuss that. So when you increase the temperature, guys, right? So everyone, can you answer what happens when you increase the temperature? Yeah, tell me guys, what happens when you increase the temperature? Yeah, so generally what we think, no, that yeah, when we increase the temperature, solubility increases. But this is not always, guys. What you have to know, yes, that the reaction, if the reaction is endothermic, means it absorbs energy, then in that case what is going to happen? Your temperature will be directly proportional to solubility. Your temperature will be directly proportional to solubility. That you can relate. So if reaction is endothermic, temperature will be directly proportional to solubility. But if reaction is exothermic, guys, it is going to be little opposite. So if reaction is exothermic, so if reaction is, very good Komal, what you can relate, if reaction is endothermic, so if you will increase the temperature, solubility will increase. But if a reaction is exothermic, what you have to know, if reaction is exothermic, so if reaction is exothermic, what is going to happen, guys? Yes, just a second. If reaction is exothermic, what we can relate? Yeah, if reaction is exothermic, it is going to be inversely proportional. Correct Komal? Veena, yes everyone. If reaction is exothermic, what we can relate? Yes, so this is what you can relate. If reaction is exothermic, the temperature will be inversely proportional to solubility. So guys, no need to worry. There are few people who are doing like trying to spam the chat box. So no need to worry. We'll be just concentrating on the topic and we'll be understanding in the easiest manner. Okay. So temperature is inversely proportional to solubility. That's what we can relate. So it means if you'll be increasing the temperature, no, solubility is going to decrease in that case. So this you have to take care, right? Very good. So generally we consider that if the temperature increases, solubility increases, right? But we don't consider this thing that yes, reaction can be exothermic also, and if the reaction is exothermic, in that case it is going to be opposite. Very good. So now let's just talk about the next thing, that is what is going to be the effect of pressure when you are talking about solubility of solid in liquid. So any effect will be there of pressure? Yes. If you are having a solid present in liquid, what do you think? There will be any effect of pressure? Yeah? No. Correct? Yes, Komal, Veena, everyone. There will be no effect of pressure. Because tell me, like, okay, everyone tell me that we have a solid in that the particles are already very tightly packed, no? Tell me, they are very tightly packed. So if you will apply a lot of pressure also, right? If you will apply a lot of pressure, what is going to happen? They are not going to get, yes, they are not going to come more closer, and if they are not going to get more closer, its solubility is not going to, yes, change in any way. So what you can relate effect of pressure is no effect when you talk about solubility of solid in liquid. Good evening, Ankush. How are you? So that's what we can relate. So effect of pressure on solubility of solid in liquid is very simple. There is no effect, because obviously they are, the particles in the solid are very tightly packed and pressure is not a dominating factor. Okay, Ankush, you are from ISC class 11. So we are discussing few of the topics from class 12, and that's going to be helpful for you, right? Obviously in the 12th standard, so you can learn. It's going to be very simple and easy. Okay, and if you get any doubt, you just let me know. If you get any doubt in any term, I will be telling you. Okay, you are the Aman who attended your class yesterday. Oh, that's good. Okay, so you joined from the different name, no? That's why I was not able to identify you. So what we are doing today is, yeah, we are talking about the solutions unit of class 12, and we started with the solubility and solubility of solids in liquid. We are done. Now let's just quickly discuss about solubility of liquid in liquid. Okay, so this is a very general topic, even you will be able to understand. So solubility of liquid in liquid, how you can relate. So it's very simple. We don't have to study about solubility of liquid in depth. Yes, we don't have to study about solubility of liquid in depth, but yeah, we have to know about few terms, right? So solubility of liquid in liquid. Now when I talk about one liquid, I'm just trying to dissolve in another liquid. Good afternoon, JEE 2024. So you can tell me your name, exact name, by that I can call you, right? So it will be easy for me, or I will be calling you G. So you can just let me know. So solubility of liquid in liquid, how you can relate. So on the basis of that, we make three types of solution. When you dissolve two liquids, right, so on the basis of solubility, right, you can have a solutions, and which you can define at what? So on the basis of solubility of liquid in liquid, you can have a solutions, yes, of three types. So solutions you can have of three types. What and all? You can have a miscible liquids. Yes, you can have a miscible liquids, you can have a immiscible liquids, and you can have a partially miscible liquids. So first one is you have miscible liquids. The next you can say immiscible liquids. You can relate with it simply, immiscible liquids. And another one is partially miscible liquids. So on the basis of solubility of liquid in liquid, we can, yes, we can define solutions of three types: miscible liquids, immiscible liquids, and partially miscible liquids. Now talking about miscible liquids, are you getting any information from the name? It's very easy, no? The liquids which gets completely dissolved with each other in all the proportions. Yes, what are miscible liquids? The liquids which dissolve, which completely, yes, the liquids which completely gets dissolved with each other, in any, very good. So liquids which completely gets dissolved with each other in any proportion, dissolved with each other in any proportion. Like how we can relate with it for the miscible liquid. Tell me guys, when you're getting a milk from the milkman at your home, right, are you able to identify that today there is 100 ml of water in the milk, tomorrow like next day it is 150 ml, or next day it is 500 ml? Yeah, very good, Aman. So what you can relate, are you able to identify? No, because milk and water, they are miscible in each, like every proportion. So what you can relate, milk plus water. Yeah, so what you can relate guys, milk plus water, very simple. These are the examples of miscible liquids. Then other than that, alcohol plus water, I was giving this example before also, that you must have seen in the movies, right? There are people, they take little amount of alcohol, add more amount of water, or take more alcohol, add a less amount of water. So when you add alcohol and water, right, you can add it in any proportion. You can add 1 ml in 1000 ml also, you can add 500 ml also, you can add 800 200 ml also, like any proportion you can add it. So this is what you can relate, you can add it in any proportion. Other than that, you have HCl plus water, these are miscible liquids. HF plus water, so they are the miscible liquids because they get dissolved with each and every proportion. Now if I talk about partially miscible guys, yes, the substance is the liquid which slightly gets dissolved. So liquids which, yes, we can write the same definition, liquids which, but instead of completely, we can write slightly gets dissolved. So if we write the same definition, we can mention liquids which slightly dissolved with each other, not completely. So that is going to be a partially miscible. Now what are the examples for it? Yes, what are the examples for it? You have ether plus water. So ether, what it is seen that it dissolves with water, but not in all proportions, so very slightly it gets dissolved. Okay, like that you have even chloroalkanes, like haloalkanes plus water, basically you can consider as RX. They are very slightly soluble, sand and water, okay, that also you can say, but that is solid, correct? We are talking about here, Aman, liquid in liquid, so that's why it is not correct. Otherwise the concept is correct, that sand is partially soluble, okay, but as we are discussing about solubility of liquid in liquid, so we have to consider liquids. So ether plus water, haloalkane plus water, these are the examples for it. Now talking about immiscible liquids, what you can relate, very simple, the same definition, liquids which doesn't get dissolved. The liquids which doesn't get dissolved with each other, you can relate, is going to be the same definition. And what are going to be the examples for it? Immiscible liquid which doesn't get, butanol and water, okay, very good Komal. Oil and water, butanol and water, but butanol is an alcohol, no? Yeah, Komal, butanol is an alcohol, so why it is not soluble in water? Yeah, so it is soluble. Alcohols are soluble in water, no? Oil and water is, yeah, vinegar and water is also like they are miscible only, no? Because in vinegar, if I consider, you have 5% of ethanoic acid which is there. So oil plus water is there, petrol plus water is there, which are completely immiscible. Yeah, that was partially miscible, absolutely correct, Gopal. So what you can relate, oil plus water, petrol plus water, these are the examples of immiscible liquids, and that's what we can relate. Very good. Now let's just talk about the next thing what we can talk about. Yeah, that is your solubility of gases in liquid, which is an important part, and generally the questions are asked from this chapter, from this topic, like from solutions, generally our questions are asked from this topic, which is solubility of gases in liquid. Because before, solubility of solid in liquid and liquid in liquid, what we have discussed, they are like very basic stuff. Now let's just understand about few of the technical things over here. So what is that? solubility of gas in liquid. So tell me guys, gases are soluble in water? Can you give any example of a gas which is soluble in water? Tell me guys. Okay. Yeah, everyone. Komal, Aman, JEE. Everyone guys. Yeah, HCl in the gaseous form, ammonia in the gaseous form. Okay, good. Other than that, if I talk about a very general thing guys, tell me, in your water oxygen is dissolved. Yeah, oxygen is dissolved in water or not? And that is the reason your aquatic animals can survive, no guys? Yes, tell me. Oxygen, carbon dioxide, you must have heard about carbonated drinks, right? All these Coca-Cola, all those Pepsi, everything, all these carbonated drinks, what you can relate with it, that in that carbon dioxide is there. That's why you call it as carbonated drink. So what we can understand over here, that solubility of a gas in liquid, it depends upon which and all things. Let's just understand. So which and all factors it depends upon? The first one is nature of solute, right? Means what gas you are taking and what you have to consider in that. So it depends upon first nature of gas. So nature of gas, what you can relate, it's very simple. If you have an easily liquefiable gas, they are more soluble in liquid. If there are two gases A and B, and A can be liquefied easily, then B, so it is easily liquefiable, so it will get easily dissolved in water. So easily liquefiable means it depends upon, like if you have a particular gas in which the particles are there, then they have a slight force of attraction. So if you are trying to bring them closer, they are coming closer and it is getting easily liquefied. So what you can relate, yes, the easily liquefiable gas is going to have more solubility in water. So what we can write, easily liquefiable, right? Easily liquefiable gases are more soluble in what guys? In water. Very simple. But how you will get to know that which gas is going to be more liquefiable and which is not going to be? So it's very simple how you can relate that. Molar mass of a gas is directly proportional to liquefiability. Molar mass of gas is directly proportional to liquefiability. So you will just check the molar mass, and molar mass is the one which has more. Like if I talk about ammonia and HCl, which will be more easily liquefiable. You can liquefy which gas easily? Tell me everyone. Aman, Komal, JEE, rest of the people. Okay, we'll discuss about it. So first everyone should answer that ammonia and HCl, out of this, which one is going to be more liquefiable, and then we'll discuss about, yes, we'll be discussing about the next thing, what Aman has asked the question. Everyone should answer guys. Which one will be easily, which one will be more soluble out of ammonia and HCl? Yeah? NH3. Very good, Komal. No, it's going to be what you can relate. Molar mass increases and liquefiability increases, no? So we have Komal and Ankush both have given different answers. So molar mass increases, liquefiability increases, and liquefiability increases, solubility also increases. So the answer, Komal, is going to be what? Because this has a 17 gram and this has gram per mole, and this has 36.5 gram per mole. So this has a more molar mass, so it will be more easily liquefied, and if it will be more easily liquefied, it will be having more solubility. So the answer, Aman's answer is correct. Correct, Komal? Understood why HCl is going to have more solubility? Yeah, because the reason is very simple. Its mass is 36.5 while here it is 17 only. Okay, very good. So this we can relate. Now one question Aman has asked that, ma'am, did hydrogen sulfide is soluble in water or not? So I told you, like in the starting, I guess you joined little late, Aman, that there are two ways to check whether a given substance is going to be soluble in water or not. First is you can check the like dissolves like, whatever is the nature of solute, if the solvent nature is also same, it's going to get dissolved. Another is hydrogen bonding. So what is found that H2S, when you add in water, it is very slightly soluble or insoluble. So we can relate that it says slightly soluble or insoluble in water. Why? Because it doesn't form a hydrogen bonding. Your H2S doesn't form hydrogen bonding. And there is a weak forces of like dipole force of attraction over here, not a strong one. So doesn't form hydrogen bonding. And because of that, it is very slightly soluble or insoluble in water. Okay, Aman? Understood that? So this we have understood the first effect, that is effect of what you can relate, effect of nature of gas, how it is going to be varying or how it is going to be changing. Yes, the solubility that we have understood. Now let's just understand about the second factor. Okay, sorry, Komal, you have asked it. Oh, by mistake. Like I was just looking at the message and I think I have read it wrong. So sorry. Yes, Komal, you understood this, no? That the H2S plus water. Okay, very good. Now the second thing what you have to know is the effect of temperature. Now this is going to be little interesting. So tell me guys, your solubility of gas, it is going to depend directly on a temperature or inversely on a temperature. Yes, what say? You have to say either directly or inversely. You can put D or I also. What do you think? Solubility of gas depends directly on temperature or inversely it depends upon temperature? Everyone should answer it. This is a very interesting thing to understand. Yeah? So you can just write D if it is directly related, I if it is indirectly related. Komal. So Aman said D directly. What about you, Komal? Rest of the people, JEE? Okay, no problem. Aman will be discussing about it. Yes, Komal, what you think? JEE, everyone? So Aman said D and Komal said I. Okay, so we got 50-50, like both are saying. Let's just see who is correct. So what you have to know guys, out of both of you, and on this question Komal is correct, that your temperature is directly, not directly, it is inversely proportional to solubility. Yeah, why? Right, so why it is indirectly soluble? Tell me, Aman, everyone, that your aquatic animals, they are more comfortable in cold water or hot water? Tell me guys, they are more comfortable in cold water or hot water? Yeah, everyone tell me. Your aquatic animals, they are more comfortable in cold water or hot water? Cold water, no? So why? What is the reason? Because in cold water you will be having more dissolved oxygen, but the moment you will heat it, you will make it hot, what will happen? Your oxygen, the gas which is present in water, will start escaping out from water. And if it will start escaping out from water, what you can relate here guys? Yes, if it will start escaping from water, oxygen will be less, and if oxygen will be less, aquatic animals will be feeling very discomfort. Correct guys? So what you can relate? Very simple, that temperature is inversely proportional to solubility. And why? Because that's why you can also always remember, that's why aquatic animals are more comfortable in cold water. That's why aquatic animals are comfortable in cold water. Very good. Because in hot water, solubility will increase as temperature increase. That is for, yeah, So solubility increases if temperature increases, that is for solubility of solid in liquid, right? And that too for endothermic reaction. But if I'm talking about solubility of gas and liquid, always remember your temperature, if it increases, solubility decreases, and this is what we can relate. Very good. Now let's just talk about effect of pressure. So as we are talking about solubility of gas and liquid, so there will be effect of pressure, obviously. Why? Because pressure is a dominating factor for a gas. Yes or no? So what is effect of pressure on the effect of pressure on the solubility of gas and liquid? So effect of pressure, what we can relate, that your solubility is directly proportional to the pressure of the gas, partial pressure over the gas. So what is S over here? S is solubility and P is the partial pressure of the gas. Okay, very good. So it is directly proportional. So more you will be applying pressure, so what will happen? The molecules, they will be coming closer, there will be more force of attraction and they will be, yes, quickly getting dissolved in it. So that's what you can relate. So solubility is directly proportional to pressure, and that we can understand. Now whenever you have a proportionality sign, if you want to solve any of the questions, you can't solve until unless you are not removing the proportionality sign. So what we'll be doing, we'll be removing the proportionality sign and we'll be putting a K over here, yes, which is the constant of proportionality. Constant of proportionality, right? So your S is equal to Kp. We introduced a constant which we can relate. But what happened, one of the scientists was there, like Dalton. He said that, okay, like you should take the solubility in mole fraction. Is solubility of gases increase and pressure will also increase. Absolutely correct, Komal. Very good. Yes, Aman. Absolutely correct. So yeah, we'll be getting to know the special name. So first, like we were knowing that, yeah, we have to remove the proportionality sign, we'll introduce some constant. But till the time, like Dalton scientist who was also working on it, he said that, okay, we should take solubility in terms of mole fraction. And when this information was given, one of the scientists named Henry came in the picture and said, okay, let me give my equation. I have also done the experiment, and he gave his own equation. So what Dalton did, Dalton said that, okay, solubility should be taken in terms of mole fraction. So Dalton said that, we were knowing this, everyone was studying on this, that solubility of gas is directly proportional to the partial pressure of the gas. What is the pressure exerted on the gas? Correct. So Dalton was experimenting that, okay, if you are taking a mole fraction, the concentration, solubility in terms of mole fraction, will be getting more accurate results. So that moment only, a scientist named Henry, right? Henry took the idea of Dalton, and what he did, he actually introduced an equation. He said that your mole fraction is directly proportional to pressure of the gas. So one scientist named Henry, let me just quickly tell you about it. So one scientist named Henry, what he did, he gave his equation on the basis of that idea, and what he gave that mole fraction is directly proportional to the pressure over the gas. And what he did, he introduced a constant, that is K dash here, and he gave it a name, like he gave the he introduced a constant K dash on the pressure side, and when he taken this 1 upon K dash to the x side, you consider that constant as KH. So what is our Henry's law? Henry's law is P is equal to KHX. What is KH here? KH is having a specific name, which is a Henry's constant. So what he said that, okay, like the same thing, solubility is equal to pressure. Then what we discussed, we introduced some constant here, that Kp. So he introduced some K dash, and he took this K dash this side on the mole fraction side, and he introduced a constant which is Henry's constant. Correct, guys? Very good. So this is your Henry's law, and that is what we can relate. So what Henry's law says, we'll just define it, and we'll be doing some of the numericals related to it in the next class. So what is Henry's law? Henry's law, what it says, that it states that, sometimes they ask you a question regarding Henry's law also. So how we can define that? It states that the solubility of gas in a liquid, is directly proportional to the pressure of the gas, is directly proportional to the directly proportional to the partial pressure over the gas. Thank you so much, Aman. That's so sweet of you to tell. So, yeah, like you can join tomorrow. There will be 11th class session, which is 5:15 to 6:15 p.m. and will be continuing with the laws of chemical combination. So make sure you are joining that. Okay, Aman. Okay. Thank you so much. So what we can relate, it states that the solubility of gas in a liquid is directly proportional to the partial pressure of the gas. Thank you. Thank you, Aman. Bye. So yeah, so Henry's law, what we can relate, Komal, Veena, everyone, JEE. So what we can relate, it states very simple that the solubility of gas in a liquid is directly proportional to partial pressure of the gas. So this is what we have talked about the Henry's law, and we'll be talking about little regarding the characteristics of Henry's constant. Let's just discuss about it. What are the characteristics of Henry's constant, and then we'll be just winding up the class, we'll be wrapping it up, and we'll be talking numericals, like we'll be discussing the numericals related to it on Thursday, same time, 5:15 to 6:15 p.m. So what are the characteristics of Henry's constant? So we have to know that the KH, which is there in the Henry's law, it has a different values for different gases. It's not a fixed value. Like if I say for Avogadro's constant, the value is 6.022 into 10 to the power 23. For Planck's constant, the value is fixed. Like that, here the Henry's constant, its value is not fixed. It is different for different gases. So what you have to know, first characteristic is the value of KH is different for different gases. The value of KH is different for different gases. First thing. Now the second thing, what you have to know, that your KH, Henry's constant, is directly proportional to temperature. Henry's constant is directly proportional to temperature, but you should know that your solubility is inversely proportional to, yes, temperature. So how KH and solubility can be related? So KH is inversely related to solubility. KH is directly proportional to temperature. It is found if you increase the temperature, value of KH for a particular gas increases, but solubility is inversely proportional to temperature. So what we can relate? Your KH is inversely proportional to solubility. KH is inversely proportional to solubility. Correct, guys? Yes. Komal J. So KH is inversely proportional to solubility, that we can relate. Okay, guys. So what you can relate, the second characteristic we have understood, that if suppose they are giving you two gases, right? Like they are giving you a question that there are two gases, gas A and gas B. For gas A, they have given the KH value as say 1.97, and for gas B they have given 2.98, and they are asking which one will be more soluble. So can you tell which gas will be more soluble? Yes, Komal, J, everyone. Yeah, which gas will be more soluble? Gas A, KH value is 1.97, gas B, KH value is 2.98. So can you tell which gas will be more soluble with the help of KH values? We should know that KH is inversely proportional to solubility. So how will we getting it? So if it is inversely proportional to solubility, so if KH value increases, solubility decreases. Yes or no? So which one will be more soluble? Gas A is more soluble. Correct, Komal? So regarding the applications of Henry's law and the numericals related to it, we'll be doing in the next class, and we'll be also talking about vapor pressure, Raoult's law of vapor pressure, and the numericals related to it in the next session. So this is what we have done, guys. What and all things we have done today. We have talked about what is solubility, what are the basic criteria to tell whether a given substance is going to be soluble or not. Then we discuss about solubility, right? We can discuss in three cases: solubility of solid in liquid, liquid in liquid, and gas in liquid. So we discussed all the three of it: solid in liquid, liquid in liquid, and gas in liquid. So that and all things we have discussed. Now let me just tell you about few of the things regarding the sessions. So guys, what you have to know, that nowadays a offer is going on an Unacademy subscription classes, that you will be getting 20% off on your ISC Board Plus subscription if you are enrolling for the course from 27th to 30th June. you can use my code, which is MRIS10, and you will be getting instant 10%, like 20% discount, guys. Generally it is 10%, but you'll be getting the double discount, which will be 20%. So you can use my code and enroll for the classes. Let me tell you about the batches which are going on right now. So we have like the batches which are going on is one of the batches, Achievers, which is there for the class 12, and this started from the 1st June, guys. And a few of the topics are done here, but whatever topics will be left for you guys, what you have to know, we'll be providing some extra classes for you, and that will be covered, so no need to worry, right? And you'll be able to understand from the first session itself every topic, so no need to worry in that case. And the Brahmastra batch is going on, which is from the 8th, like which started from the 8th June. Yes. And what you can relate, guys, this is for class 11. So if you have any friends or siblings which are there in the class 11, you should inform to them who and all are taking the classes in these batches. So I'm taking the chemistry classes in this batch. Mohana Thara ma'am is taking physics class. Maths is taken by Jyoti Lakshmi ma'am, and biology is taken by Lakshya Gera sir. So we all will be taking the classes for all the subjects, guys, and the respective timings for the classes are also mentioned. Okay, very good. So let me introduce you about community as well, guys, which is a special feature of our Unacademy app. So in community, guys, we share each and everything. Like, you will be getting all the updates from your favorite teacher regarding the classes, the topics, which and all topics you are facing difficulty, which topics you want a special class, right? You will be getting all the session notes, all the practice material, and you can share your feedback directly with the educators via polls. So that's what you can do. So you can join the community, and you will be getting all the information. So this is what and all things we have done. Let me just quickly tell, and I'll be telling you what and all things we'll be doing in the next class as well. And before that, I want to tell one more thing, guys, that today we'll be having a special class. Yes, what you have to know, today we'll be having a special class 6:30 to 7:30 p.m. Today there is a special class 6:30 to 7:30 p.m. on our Unacademy app, and that is related to name reactions related to alcohols and phenols. Name reactions related to alcohols and phenols. So we'll be discussing that. So all of you can join. Yes, Komal, JEE, everyone, you can join this special class on our Unacademy app, which will be the name reactions related to alcohols and phenols, and we'll be learning many tips and tricks that how you can learn the name reactions easily, how you can understand it easily. So that and all things we'll be learning. Okay, guys. So make sure everyone is joining the session. Yeah. So everyone, yes, if anyone is having any doubts, any queries, any feedback, you can tell. So I hope Komal, JEE, everyone, you enjoyed the session. And if you have any queries, you can ask. Yes. Tell me, guys. Komal, Veena, JEE, everyone, any doubts, any queries? So, okay, guys, we'll be meeting in the next session then. Thank you, all of you. Bye-bye. Bye, everyone.